In order to identify a salt, what should the approach be? You identify the cation using suitable reagent, and you identify the anion using suitable reagents, and then you fuse them together and you get your salt. All right, so now let's focus on your cation. To identify a salt, to identify a cation, you have two reagents. One, sodium hydroxide solution. So I put it as aqueous. The other one is ammonia solution. These are the two. All right, so now we are looking at the basis upon which these two are used in identifying the cation. Okay, so I've already done this with you. Okay, so before you go into that basis, you have to know that all hydroxides are insoluble. I want you to know that, except group 1 hydroxides, okay? And maybe there's a few exceptions like barium hydroxide. Barium hydroxide is soluble, okay? So let's stick to group 1 here. Okay, so that's your basis, because you will not be coming across barium and all that, okay? So based on that basis, so let's say you have a cation, okay? You have a cation, all right? This is your cation. And I'm adding sodium hydroxide to test the cation. So your basis is, when I add sodium hydroxide, my sodium hydroxide contributes two ions, Na plus and OH minus, which we can use for its testing. All right, which we can use for its testing. But actually, which are we using? So I want you to use your analytical power. I want you to use your common sense a bit. You should know I'm testing for cation. A cation will never attract a cation. They will repel each other. Therefore, it must be the hydroxide ion that is being attracted. So your Xn plus will be attracted, okay? So it will attract the OH minus. OH minus will attract and form what you call a compound. They'll form a compound. Now, if this compound is soluble, dissolves, you won't get anything. You won't see any observation. There'll be no observable change because it dissolves. It is soluble. But if it is a precipitate, this one, look at the logic, look at the basis. If it's a precipitate, it will appear as a solid substance. Okay, it will appear as a solid substance floating on the solution. All right, or suspended in the solution. And we can observe that. So it becomes an observable change. We are banning on that. We are banning on this being insoluble. We are banning on this being what we call a precipitate to help identify the cation. That means for this test, to use sodium hydroxide to test for cation, the cations that can be tested using sodium hydroxide are all cations whose hydroxides are insoluble. That's the basis. That means what type of cation is tested using sodium hydroxide and ammonia solution? All right, cations whose hydroxides are insoluble. That's the basis. Capture that. Capture that. And now ask yourself, what hydroxides are insoluble? Most of the hydroxide except group 1. Except group 1. Okay. So now I give you Cu2 plus. Let's say the cation is Cu2 plus. Let's say the cation we are testing is Cu2 plus. We add sodium hydroxide. So when you add sodium hydroxide, it's the OH minus. We already know, which will react with Cu2 plus and you will get CuOH2. Now, is that a group 1? It is not. So if that's the case, it is what? It's an insoluble hydroxide. Therefore, it forms a precipitate. Okay? And it will be suspended out in the solution. You can see it. Now, in fact, this is even extraordinary because copper gives you a blue color, therefore you get a blue precipitate. So not only it forms a precipitate, it gives you a blue color. Therefore, a blue precipitate is formed, which without any doubt straight away you can say the cation present is Cu2 plus. So just now I asked you, what's the cation? Answer is Cu2 plus. What's the precipitate? Identify the precipitate. Your answer is copper 2 hydroxide. That's your precipitate. Now, is that a salt? This is definitely not a salt. This is a base. Okay, this is a base. Hydroxides are base. They are not salt. That's the concept. Okay. Now, let's say you use your NOH and you add to Fe2 plus. Now, same thing. Your OH minus will react and you'll get FeOH2. Again, you look at that. It's insoluble and will give you a precipitate. But because it is Fe2 plus, it will give you a green precipitate. The green appearance will be like dirty green, green precipitate. So this will be your observable change. Again, when you get a green precipitate, 100% you can say it is Fe2 plus. All right, the cation is Fe2 plus. Now, in the same tune, if I were to add sodium hydroxide to Fe3 plus, all right, again the OH minus will react and I will get FeOH3. All right, FeOH3. This is again an insoluble hydroxide. Again, you will get a precipitate, and Fe3 will give you a brown precipitate. So if you get a brown precipitate, it shows the cation is Fe3 plus. Okay, this in your SPM are the 3 colored precipitates when sodium hydroxide is added. Now, the other cations, which is in your list of identification, will give you a white precipitate. Okay, white precipitate. Okay, so now we go into that. So they are your their Mg2 plus and Ca2 plus. These two will give you MgOH2. Now we already know it is the hydroxide that reacts. CaOH2. Again, they are both not group 1. Therefore, both gives you a white precipitate. All right. And then you have your Pb2 plus, and you have your Zn2 plus, and you have your Al3 plus. All these will give you PbOH2. Again, the hydroxide. ZnOH2, AlOH3. All this will give you hydroxide, and all of them are white precipitate. White precipitate. Okay? So if a white precipitate is formed, you have 3 cations as your choice. But which one you can't tell. But for this white precipitate, there is an additional point to remember. If I keep adding the sodium hydroxide in excess, this white precipitate do not dissolve. They remain as precipitate. Whereas this white precipitate will dissolve due to complex ion formation. What is a complex ion? You don't need to know. But due to complex ion formation, this white precipitate, they dissolve and form a clear solution. So if you get a white precipitate, add the sodium hydroxide in excess, and if it dissolves in excess, you can, from 5, you can narrow down the list to 3. But within these 3, you can't tell which. But if it doesn't dissolve, from the 5, you can narrow down to 2. But within these 2, which you can't tell. But at least you can predict which 2. You have narrowed it down to 2. That's your basis of identifying your cation using sodium hydroxide.